Hi, good day to Dr. William and my fellow friends. In this video, we will be presenting about finite element analysis on a selected engineering component. Before I proceed, I would like to introduce myself and my team members. My name is Muhammad ZULHILMI bin Muhammad FIDAA, and my team members are Ahmad IYAD bin Muhammad NOOR and Muhammad IZZAT AQMAR bin ABDUL RAHIM. So for this project, we have selected wheelbarrow as our model. As we know, wheelbarrow is used to carry and move loads such as dirt, concrete, gravel, and it is mainly used in building works and industry. Basically, a wheelbarrow consists of body frame which is indicated by yellow color, bucket, a wheel, and exit brackets. A standard wheelbarrow is not particularly stable and it carries a heavy load that can cause severe failure. It is important to know the maximum load that can be applied and determine the critical part on the wheelbarrow. So, FEA is used to simulate and analyze the effect of different load cases. We choose body frame of the wheelbarrow as a model in the simulation. So for this project, we have studied different type of load cases, which are wheelbarrow is being lifted upward to remove the load from the buckets, and wheelbarrow climbing up an inclined plank.
Hi, my name is IYAD bin Muhammad Noor and I'll be explaining about load case 1. So for the first case that we choose that is when wheelbarrow is being lifted upward to remove the load from the bucket. And the mesh parameter that we use is fine 11.5 millimeters and high quality. We use the same mesh parameter for the case 2. The the method that we use to choose this mesh parameter is by try and error to find the minimum and the maximum mesh parameter that the SolidWorks can render. And after finding the minimum and maximum mesh parameter, we plot the output to see at which value that the output converges to, so that it shows little variation between the output to make it more precise. However, based on the graph that we get down here, the value of the output does not converges into one value. So we just decided to choose the minimum mesh parameter with high quality to get the most accurate result. So and then for the assumption that we made for this case is first one, wheelbarrow is assumed to be lifted outward at the point where link 7 does not touch the ground. Link 7 is this one. We assume it does not touch the ground is to avoid having reaction at this link. The method that we use to find the magnitude at F4, F3, F5, F1, F2 is by using a FBD analysis method. And if we have the reaction F at link 7, it will be hard to find the magnitude of these forces. So we assume at the angle of lifted upward is at the point where it does not touch the ground. So for the second assumption is that the weight of frame and bucket and the load weight is assumed to be uniformly distributed at link 1, 2 and 5. 3. The force applied between link 1 and 2 and link 5 is equally divided. Link 1 and 2 and 5 are equally divided, which means that link 5 withstand 50% of the total weight. Link 1 and 2 withstand 50% of the total weight. The fourth assumption is that the force applied at link 1 and 2 is equally divided at each side. That means that the 50% of the total weight is divided again by 2 for each side of the link. The fifth assumption is that the link 3 and 4 is assumed to have zero force distribution. As can be seen in this figure, from the side view of the wheelbarrow, we see that the bucket does not actually touch that link, so we assume it to have zero force distribution. After doing the FBD analysis, we find the magnitude of all the forces and we input it into the SolidWorks software, and we get this Formister stress distribution result, as can be seen in these figures. And the maximum stresses, which is 328.2 megapascal, appear at the link between link 2 and 5 and link 1 and 5. Link 1 is this one, link 2 is this one, and link 5 is the upper part here. It appears at the red region here, and it is the only place where the red region appears. So it shows that this is the only critical part for this case. And we found that there are two main reasons to explain why this occur, which is high it appears because of the high bending moment and stress concentration factor. As you can see, based on the allocation of the forces, all of these forces contribute to the bending moment at this part. And some of the forces have long perpendicular distance, such as the force at the handle. So it produces a high bending moment, which can increase the stresses at that part. The second factor is the stress concentration factor. Between the connection between these two links, there are drastic change in cross-sectional area. The drastic change of the cross-sectional area causes a high stress concentration factor, which further amplifies the bending stress at that part. For the displacement distribution plot, we can see that the red region appears at the handle and the color gradually turns into blue as the distance gets closer into the fixture. This result actually suits with the application where to remove the load from the wheelbarrow it requires half of the frame to be lifted upward while the other half of the frame to be maintained static at the ground. However, for the safety factor distribution plot, we can see that almost every part of the frame has red regions, which shows that this case the load will cause every part of the frame to yield. And when we have the maximum value of the maximum stress and the yield strength of the material, we can find that the minimum safety factor is 0.52, which is at the welded part. However, it's important to take note that the value that we choose is the average maximum load that wheelbarrow can carry, which is around 520 kg. So it's unusual that it can happen at everyday life. However, we still choose this magnitude as the project requires us to choose the critical application. After doing the analysis based on the result that we get from the solid work, we come up with the 2 points to increase the safety factor of the frame. The first point is choosing a stronger material that have higher yield strength. And the second point is by improving the design by considering the dimension of the frame so that it can reduce the bending moment stress and also the stress concentration factor at the critical part, which at this case is at the welded part.
Hi, my name is Muhammad AQMAR. Now I will talk about load case 2. For load case 2, the situation is a man is pushing a wheelbarrow up incline plane. So for our case, we said that the incline plane is 15-degree angle. So the mesh parameter is also same with the low case 1, which is high quality and fine 11.5 mm. So our assumption for this case, the center of gravity is near with the handle because of the inclined plane. Next, the weight of frame, bucket, and load weight is assumed to be uniformly distributed in link 1, link 2, and link 3. Force also equally divided at link 1, 2, and 3. Also with the lifting force at the handlebar is uniformly distributed. This is because to simplify our calculation. So for the force, we use free body diagram method to find the value of the force, which is at the handle, the center of the gravity, and reaction at the wheel. So for the link 4, we assume that it will have no force because the bucket will be not contact with that link. This is because we assume that the bucket will move backward while climbing up the inclined plane. Next, after we done with the FBD analysis, we continue with bond basis stress distribution. Same with the load case 1, we input the force that we obtain from the calculation. into the all the frame and we run the simulation, and these are the result that we get. So the maximum stress is occur at the wheel bearing mounting and the welded pipe with the link 5. The value is 191.7 megapascal. So for the minimum stress, it's occur at the blue region and the minimum value is 8.06 kilopascal. So we know that the red region is the most critical part for this case, which is at the welded pipe with link 5 and the bearing mounting. So this is same with the load case 1, which is due to the height bending moment and stress concentration factor. Next, we find the displacement and safety factor distribution. For the left figure is the displacement, for the right figure is the safety factor distribution. So for the displacement distribution, the red region is the maximum displacement, which is 3.35 mm, and it's appear along the handlebar and the link 1. So the blue region is the minimum displacement, which is around the fixture with the wheel bearing with the value of 0.01 mm. Other than that, the other link, which is 2, 3, 4 and 6 result in show a green region, which is implies that the moderate displacement. So as we know that the center of gravity is near with the handle along the handlebar and the link 1. Therefore, it is very reasonable why this part have a maximum displacement. So for the safety factor, we can observe that all the frame is the red region because we use the maximum usual weight that the wheelbarrow can carry. Therefore, all the frame will fail and yield as we get the minimum safety factor is 0.9. Next, to enhance the safety factor, same with the load case 1, we can use the equation of safety factor and equation of bending stress. For example, the first one, choosing the stronger material with the higher yield strength, and the second one is improves design to reduce the bending moment and stress concentration. For example, we can put a support link along the handlebar to reduce the bending moment and to reduce the maximum displacement.
To conclude, for load case 1, the maximum stress is 328.2 megapascal, while for load case 2, the maximum stress is 181.7 megapascal. From this, it can be seen that load case 1 has a higher maximum stress compared to the second case. Furthermore, the critical stress happen at different part, which is at the welded joint for load case 1 and at the wheel bearing mounting for load case 2. As for the maximum displacement, it occurs at handle frame parts for load case 1, while for load case 2, it happened at the along handle frame and also happened at the frame parts at link number 1. From the simulation, safety factor for both load case 1 and load case 2 is 0.52 and 0.9 respectively. This shows that the first case is the critical one since the safety factor is lower than the second case. As stated before, the applied load on the model is 520 kg, where it is a maximum weight a wheelbarrow can carry. So it is expected that the safety factor for both cases is not high enough since the safety factor is not to exceed 1. However, some modifications and improvements can be done to increase the performance of a wheelbarrow, such as material selection with a higher yield strength and improve the design that can reduce bending moment as well as stress concentration at the critical parts. So that's all from us. Thank you.